Perseverance rover is making a steep ascent to reach unexplored Martian territory. The Perseverance rover has begun a long climb up the steep rim of Jezero Crater on a quest to discover some of the most ancient rocks on Mars and the potential for environments that may have once hosted life on the red planet. Landing in Jezero Crater 312 years ago, the robotic explorer has since explored the site of an ancient lake and river delta and collected numerous rock samples. But its latest scientific journey could rewrite the way astronomers understand Mars. Perseverance has completed 4 science campaigns, collected 22 rock cores, and traveled over 18 unpaved miles 29 kilometers, said Art Thompson, Perseverance project manager at NASA's Jet Propulsion Laboratory in Pasadena, California, in a statement. As we start the Crater Rim campaign, our rover is in excellent condition, and the team is raring to see what's on the roof of this place. The rover will use its auto-navigation capabilities, which allows Perseverance to function like a self-driving car, to follow a route planned by the vehicle's engineers. The route will enable the rover to avoid hazards on the challenging climb. Perseverance will gain about 1,000 feet 300 meters in elevation when it summits the rim toward the end of 2024. This ascent is something scientists have been looking forward to for years, long before Perseverance landed on Mars. About 4 billion years ago, some kind of object slammed into Mars and created Jezero Crater, and the impact kicked up huge blocks of rock that became trapped in the crater rim. We should be able to access and sample some of the oldest rocks on Mars in the crater rim, said Bryony Horgan, co-investigator on the Perseverance rover mission and professor of planetary science at Purdue University in West Lafayette, Indiana. We think these include everything from ancient sedimentary rocks that could preserve the earliest habitable environments on Mars, to the building blocks of the planet that formed the earliest crust at the dawn of the solar system. The crater rim will provide a window into the earliest period of Mars history and could reveal evidence of hot springs that might have supported ancient microbial life, Horgan said. Turning back Martian time, the impact that created Jezero Crater also generated a lot of heat. Partly from the energy of the object that slammed into Mars, some of the heat also came from hotter rock that existed beneath the Martian surface, as the planet was still cooling after forming 500 million years earlier. The impact churned up those rocks from below the Martian surface. If groundwater or surface water was present on Mars at the time, which scientists believe likely, there would have been hydrothermal systems, said Ken Farley, Perseverance project scientist and professor of geochemistry at the California Institute of Technology. With hydrothermal systems, hot water likely circulated through cracks on rocks and may have created the right environment for microbial life to thrive. So far, Perseverance has investigated the site of the ancient lake bed and river delta, where life could have existed. The crater rim site of Pico Turquino, as the hydrothermal rocks are called, provides another, different possibility. In the scheme of the overall objectives of the mission, looking for evidence of possible life on Mars is very high up there, so we want to investigate as many potentially habitable environments as Mars will offer us, Farley said. The science team is also eager to reach Witch Hazel Hill, a large outcrop of black and white layered rock that extends for hundreds of meters. These layers of rock may preserve information about Mars' climate billions of years ago. The rover should arrive there in 6 to 9 months. The movement of plate tectonics and other erosive processes have erased some of Earth's earliest rocks, but ancient rocks encoded with the history of Mars still exist on the red planet. The solar system formed 4.55 billion years ago, and the science team expects to find and study Martian rocks that are 4.2 billion years old, Farley said. Ascending the crater during the long drive up the crater wall, Perseverance could encounter slopes angled nearly 23 degrees. Typically, the team avoids any route that will tilt the rover more than 30 degrees. But the rover is well prepared for the climb and isn't in any danger, Farley said. Climbing up the crater rim, even though it would be a bit of an arduous journey for us humans, from a rover standpoint it actually won't be that big of a deal, said Stephen Lee, Perseverance deputy project manager. But the rover's rate of progress may slow if it feels its wheels slipping on the Martian terrain or encounters big boulders during the climb. Perseverance can watch the terrain as it drives, and if its wheels slip too much, the rover will stop and call home for mommy, wait to be told what to do, and will figure it out on the ground, Lee said. The rover remains in excellent condition, with no showstoppers in any way to say we can't continue operating this vehicle for many more years, Lee said. By the time the rover climbs to the top of the rim, it will have traveled tens of kilometers more and captured tons of new images for the mission team to analyze. It's a unique perspective for those of us who get to work day-to-day on the project, Lee said. Pretty soon you start to get a sense of Mars as a place. My memories of Perseverance's traverses are a lot like memories of a hike. I can actually think of what Mars is like from the landing site all the way to where we are today, and the rover's perspective above the 28-mile-wide, 45-kilometer-wide crater will provide some beautiful vistas. We will definitely get some amazing views looking back where we came from in Jezero and out into the plains beyond, Horgan said. The biggest challenge will be for the science team, as it determines which rocks to study up close as well as the ones from which to collect samples. With so many intriguing school bus-sized piles of rock, the team will have to learn as much as it can while keeping the rover moving. We'll have all of this stuff just thrown out in front of us, Farley said, so I think it'll be a very different kind of exploration. The team anticipates that Perseverance will spend at least a few years beyond the crater rim collecting samples. Meanwhile, the question looms as to how those samples, along with the ones Perseverance collected within the crater, will return to Earth as NASA reassesses the Mars Sample Return Program. The agency is evaluating different proposals and is expected to announce a decision in the fall. The decision could determine how long and how far the rover drives, since the vehicle may be responsible for delivering samples to a spacecraft to carry back to Earth. This part of the mission is essential for creating a sample collection that is the collection of everybody's dreams, Farley said. For now, we're just going to pursue our crater rim investigation. And then when the time comes, we'll do whatever we need to do to support Mars sample return.